Hi, I'm Granny, and we're going down the rabbit hole of when the Earth's magnetic field failed. I've done episodes on the auroras and the Earth's tectonic plates, the moon, our universe, which all have involved the Earth's magnetic field, and watching them again may help you understand this episode better. The episodes that I did on volcanoes also were involved in understanding how our pole's magnetism reverses itself periodically. Like the last time they said it was like 240,000 years ago that it reversed its magnetism. So it's good to remind ourselves that living on this earth today and what it's like is not what it was like 100,000 years ago or 100 years ago. A recent study stated that 41,000 years ago, the Earth's magnetic field nearly collapsed. It discussed a cascade of environmental and biological changes. This event is called the Lachamps excursion, lasting about 2,000 years. Scientists estimate the Earth's magnetic field dropped to 10% of what it is today. The magnetic poles wandered from current locations, and when I did the episode on the poles, there is a geologic North Pole and a magnetic North Pole, same with the South Pole. The Earth's magnetic field tilted and weakened, behaving more like the multipolar magnetic poles of outer planets. And when I did one on our solar system, we talked about that. The Earth's magnetosphere protects us. I should pronounce that better. The Earth's magnetosphere protects us from high energy particles from the sun, preventing them to pierce the atmosphere, harming life on Earth. The Earth's magnetic field is generated by the flow of molten iron in the outer core, inside the Earth. This field forms the magnetosphere, a vast bubble. It's described like a bubble around the Earth, that deflects charged particles from the sun. This protective layer allows the Earth to maintain its atmosphere. Anyway, go see my other videos. Preventing ozone loss and supports life. Without our atmosphere, there is no life. Charged particles stream toward the planet as solar wind. The magnetosphere bends and stretches to help protect the Earth. In the polar regions, the interaction between the plasma and the atmosphere creates the auroras. And remember how we discussed at what level or atmosphere it hits. It determines whether the auroras are blue or purple or red. Anyway, and when I would recommend you watching videos because the auroras are just magical. The Earth's magnetic field also protects our technology. That includes communication satellites, power grids, space weather, think of GPS, cell phones. Learning and understanding what happened 41,000 years ago during the Lachamps event is a reminder that what Earth is like today can change. During Earth's history, its magnetic poles have wobbled, weakened, and even flipped direction entirely during events called the geomagnetic reversals. Sometimes instead of a full flip, it's a partial flip. It's different. The field experiences shorter and more rapid changes. As I mentioned in earlier videos, it is by studying lava flows that we understand how these flips have, or how often these flips have occurred. And it is through the lava flows and the sediment deposits we learn about these changes to the Earth's magnetism. During that last excursion, they referred to, the magnetic field lost much of its strength and the poles wandered and the protective bubble weakened and space plasma patterns changed dramatically. A recent research led by Agnit Mukhopadhyay at the University of Michigan, and I'm sorry if I pronounced that incorrectly, provides insight into what the Earth looked like during this time, during that excursion. They used advanced computer models, creating a three-dimensional view of Earth's magnetic environment during that excursion. This model included three layers: geomagnetic field, the space plasma, and the auroral regions, which were much larger than they are today. They discovered that the weakened field allowed auroras to appear not just near the poles, but all over Europe and northern Africa. More solar radiation reached the ground, probably causing major effects on the Earth's atmosphere, maybe alternating its chemistry and circulation. Think of how the currents in the ocean circulate, how the wind patterns, jet streams, how they could have been influenced. We know around the time of the Lachamps excursion, Homo sapiens and Neanderthals coexisted in Europe. It was shortly after this period that Neanderthals vanished. And some people pronounce it Neanderthals, some people pronounce it Neanderthals. I don't know which one is correct. I suppose where you're located on the Earth. An article in Science Advances, April 2025, Mukhopadhyay, anthropologist Raven Garvey, and a global team of researchers worked to piece together clues from archaeology, geology, and climate science. It is their opinion that the weakening magnetic field caused a spike in human behavioral changes. And I'm simplifying it. They went into greater detail. Read that article if you're interested in greater details. It appears that clothing is one of the key adaptations. Archaeological evidence from the Homo sapiens sites show the use of needles, awls, scrapers, they believe tools likely used to make tailored garments instead of animal skins. The study believes fitted clothes offered more protection from both cold and solar radiation. Garvey believes tailored clothing allowed people to travel further from shelter and may have provided an unintended benefit, a barrier against damaging ultraviolet rays. Also, during this time, there is evidence that Homo sapiens began using ochre in their art, but also they believed as a prehistoric sunscreen because they've tested it and it does block ultraviolet radiation, which is really pretty cool. Mukhopadhyay stated changes, quote, specifically an increase in the use of caves and an increase in the use of prehistoric sunscreen. He also warns, if we had a repeat of the Lachamps excursion, quote, our communication satellites would not work. Many of our telecommunication arrays, which are on the ground, would be severely affected by the smallest of space weather events. He continued by stating that the power grid would be at risk, navigational tools would be unreliable, think of GPS, and how many people have found their way home using GPS instead of maps. Radiation levels would rise, specifically or especially at higher elevations, think of air travel. This research highlights the importance of understanding how magnetic field fluctuations could impact daily life. Mukhopadhyay concluded, quote, looking at prehistoric Earth and especially at events like this helps us study exoplanetary physics from a different vantage point. Life did exist back then, but it is a little different than it is today. Thanks for joining me. Please join me again when Granny goes down the rabbit hole. Please subscribe and share. Thank you.